Hi guys, this calculation is on the last worksheet that you guys got on Friday, which is limiting and access reactant calculation. On this worksheet, if you notice, all the rules that you took in the notes are actually listed here. So first thing it says is write down and correctly balance the chemical equation. Then it says calculate the molar mass. So I'm going to go ahead and do that exactly. Over here it says 23 for this first problem. It says 23.4 grams of calcium formate. So make sure you know how to calculate the formula of calcium formate. It's CaHCO2 plus 17.9 grams of manganese sulfate. All right, manganese has a charge of 3 because I give you that. Sulfate has a charge of 2, -2. So you swap the charges. And then it says that it's a double replacement. So we're just going to swap our cations and we get calcium sulfate and MnHCO2. Hopefully everybody remembers that the metals are the cation. Then we need to balance this, okay? So sulfate here in the reactant side is 3 and on the product side is 1. So I'm going to put 3 here. This makes my calcium 3. I'm going to put 3 here to balance that. My formate on the reactant side becomes 6, and I'm going to put 2 here to balance in the product side. So now my molar mass is 130.12, 398.09, and then 136.15, and 190.00. Okay. So let's go back to our rules and see what it says. It says set up 2 3-step conversion tables. The first table is for converting grams of R1 into grams of R2. So which means R1 is the reactant and R2 is the other reactant. So let's just make this, we're going from grams of A to grams of B using our mole map. So I'm going to write down what I'm given, 23.4 grams Ca2, extend this line, and then let's go back to our mole map and see what it says. So we are going over here, grams of A, and we are going to do 1 mole over molar mass in grams. So let's go back. 1 mole CaHCO2. All right, and molar mass we've already calculated. Ca. All right. Then let's see what the next step is, going from gram of A to gram of B. Next step is go here. Mole B over mole A. All right, so we're going to do that. Let's go back. And mole B in our example is manganese sulfate right here. And this should be 1, right? Because everything else is balanced. So I'm going to use, this is the only time you're going to use your mole ratio from the balanced equation, okay? When you're going from mole of one to the mole of the next. All right, so that's my mole B. And mole A is 3 CaHCO2. So make sure you can balance the equation, write the formulas, because those things are what are going to help you get your answers. Now we are here, mole B, and we got to go up, and we're going to use molar mass in grams over 1 mole. So let's go back. And this is molar mass in grams of grams of B. Okay. So let's see, 398.09. Mn2SO4 and then 1 mole Mn2SO4. Okay, so I'm going to show you why it's important to write all these units over and over. So grams are going to get canceled with this gram, moles are going to get canceled. This should have been 3 mole. All right, this is going to get canceled, and then 1 mole. This mole is going to get canceled. You're not canceling the numbers, just the units, okay? So then you're going to put it in your calculator. And when you do that, you should get 23.86 gram Mn2SO4 parentheses 3. All right. So for 23.4 gram, what this calculation shows us is that for 23.4 grams of calcium formate, you will need 23.86 grams of manganese 3 sulfate for this reaction to take place. But you're only given 17.9 grams of manganese 3 sulfate. So just by looking at this, I can understand that this is my limiting, right? And my excess is going to be the calcium formate. So, but we still have to continue with the calculation because the second step says the second table is for converting grams of R2 given into grams of R1. All right, so I'm going to use same thing, going from gram B to gram A, gram B to gram A. So let's put down our 17.9 grams of Mn2SO4 extend this line, and let's go to our mole map once again, and I'm going to show you this only once. We're going from gram B. So this time we're going from gram B, we're going here, we did this one, and then I'm going to do mole A over mole B, and then molar mass in grams. So just follow your mole map. All right, so we are going to put one, actually let me just use that, mole Mn2SO4 all right, and you're going to use the molar mass which you calculated. All right, and then it was mole A calcium formate. Notice we're just trying to figure out which is our peanut butter, right? Because that's what the sandwiches were dependent on in that example the other day, because that was limited. All right, so now I'm putting the molar mass of A. If you follow the mole map, you will see that it says grams molar mass on top, and then 1 mole. It's just redundant over and over, and now that you're comfortable with the mole map, you can do this, okay? So this is easy. Grams are canceled, mole units are canceled, mole units are canceled. Notice I'm not canceling the numbers, just the units. So once you get done with the calculation, make sure you plug them in as you see it. 17.99 divided by 39.09, 398.09, multiply by 3, multiply by 130.12, and you should get 17.56 grams of CaCO2. So the way to make sense of this is, for 17.9 grams that I've given you in the question, for manganese 3 sulfate, you only need 17.56 grams of the other reactant. But I've given you extra 23.4. So this is the excess. So now so basically your products are dependent on the limited reactant, because that's the one that's going to control how much of the product you make. So you're going to, your limited is the Mn2SO4. So we're going to go ahead and put that down here, 17.99 grams Mn2SO4. So now you're going to use this value to calculate how much of the products you can make. All right. So once again, we're going gram of A to gram of B. Follow that in your mole map, or you can do gram of B to gram of A. Either way, it's just going to give you the same calculation. Doesn't matter. Okay. And then this time my B is going to be this one of these products, calcium sulfate. So I'm going to put 3 mole calcium sulfate, all right? And then 1 mole. So the stuff at the bottom here is going to get canceled out, and you're going to get your product over here. And then put the molar mass on the top in grams, CaSO4. and then 1 mole CaSO4. And this calculation should give you 18.46 grams CaSO4. And notice you can go ahead and cancel these again, right? That's why it's important to put all the units in, okay? All right, and so that you're left with grams. So now let's continue on with our other calculation for the other product. So same thing, go ahead and write this down here. And actually, I didn't go back up in the rules, but you can kind of see it tells you once you complete this conversion greater than the amount you're given, then R1 is your limiting. And I kind of talked about that, okay? So 5 is 2 more 3-step conversion tables. So this is where we are right now, all right? So once again, it's redundant. Once you figure out how to use the mole map, which I think everybody at this point knows, we're writing the same thing over and over, just changing the ones we need, okay? So now this time I'm going to use this as my other product, and I'm going to use this whole thing. So I'm going to put 2 mole MnHCO2. So mole ratio, once again, is where really you're using your balanced chemical equation. All right, so that's why it's important to know how to balance, okay? And this 190 is the molar mass of your manganese 3 formate. Mn. All right, once again, when you do the math, you'll get 17.17 HCO2 3. All right, so now look at the last step. All right, here, actually, let me just show you this, get done with this as well. So these units are going to cancel. This is going to cancel. This is going to cancel, and you're left with grams of manganese formate. All right. So next we are going to look at, we're doing this right here, which is add the 2 product masses P1 and P2. This is the total mass of products made. Add together the given amount of limited reactant needed. Okay, so we're doing the last step now, and it's very simple. So what you're going to do here is you're going to take the products that you made with your limiting reactant. Let's go ahead and put them here. And then okay, so when you add them up, you'll get 35.45 grams or 0.456, depending on how you round it. And then here, I'm going to put my reactants. And then this, okay, 17.56 calcium HCO2. All right, and this is coming from here. Okay, so basically you're using these 2 numbers for the reactants, because that's how much of the other reactant you're going to use, and you get 35.46. So look, the total mass was conserved because this is the total amount of reactant used, and this is the total amount of products that were made. So if you still have any questions, please rewind this and take a look at it. We're constantly using the mole map and doing these conversions, all of these conversions, and I've used the mole map 1, 2, 3, 4 times. Okay, so watch it again. If you still have any questions, ask me tomorrow. All right, thanks.